is everybody today? We are going to pick up with 4C, and then hopefully get into 4D as well. I wanted to remind everybody that today your data for the penny flip project is due. It looks like 6 people have contributed their data so far, so great. Thanks for doing that. Let me share with you again, if you're like, I don't know where to find this or where to go. Let me share my screen. So in our e-online shell, I even put a link to it right here. This penny flip project class data. Okay, so when you click on that, it's going to take you to this Google Sheet. At the bottom, just scroll right now. It looks like our class average is we have a probability of heads of 54.29%. The reason I know it's that one is because that's the last place that we have a head or tail recorded for. And so then if you have not added your data, then you would just start in the next space down. So again, people need to add their data by tonight so that everybody has time to complete that portion of the project, because the project is due Thursday. In the meantime, we have our exam due today. And so that means that our session tomorrow is optional. I will show up, obviously. Great time to ask me questions about Unit 4 stuff, or ask me questions about the project itself, right? The Unit 3 project, because that's not due till Thursday. So I will still be here tomorrow. And so it's an optional session. If you feel like showing up and asking questions, great. If you don't, that's also okay as well. Okay. Before I move back into the work for our notebook stuff, are there any other questions?
When was the test due again? Sorry.
It's due today.
Okay, thank you.
Yep. The one other problem from 4B that I wanted to talk about that we were graphing is this problem number 4 here. And the reason why I want to talk about that is because the equation looks a little bit different, right? We've got y equals negative 1/2 x. And we remember this is from 4B, where we're talking about slope-intercept form. And if I write y equals mx plus b underneath, you'll notice that the negative 1/2 lines up nicely with the m. So our slope is equal to negative 1/2, but there's no plus b amount on the end. And so when you don't have anything written on the end, that's when we would associate the y-intercept with the point 0, 0. So it's the origin, right? If there's nothing written on the end, we think about that as like plus 0 basically. And if it's going to be plus 0, then that is the point 0, 0. So in order to graph this point, we would start by putting our dot at the origin right there, and then using our slope by going down 1, right 2. So from here down 1, right 2, and we can do that a whole bunch of times in order to graph our points. And once we graph the points, we can obviously draw our line. So that was the only one that I didn't get a chance to touch on last week before we ended class on Thursday, that I did want to touch on today before I move forward with what am I moving forward with? I'm moving forward with 4C. So again, what questions are there before I get started on the new material? Okay. All right, so 4C is writing linear equations. And so we're just going to continue again with the idea of using slope-intercept form, right? So it says write an equation in slope-intercept form to model the situation and then solve. So we're dealing with slope-intercept form. So it's going to be y equals mx plus b. Now, this is kind of related to what we were talking about last week, where the alternative way to write it is y equals your rate of change, right, times x plus your initial amount. And I find that's helpful to think about when dealing with these word problems, okay? So in number one, it says the price of a particular model car is $18,000 today and rises with time at a constant rate of $900 per year. So rises, that means we are going to have a positive slope because it's increasing, right? If it said that it decreased by a constant rate of $900 per year, that would be a negative value because it's going down. So that would give us a negative slope. So again, the first part is we want to model this. So you want to define your variables. So I'm going to say C is my cost and T is my time in years. So I'm going to say my cost is equal to an increase of $900 per year plus my initial value of the car. Okay. Another way we can write this, because you have a homework problem that sets it up this way, is you could say that the cost is equal to your initial amount plus the increase plus the 900 per year. So again, it's possible that you will see it written that way in your homework. The problem I'm talking about, as long as it's still the same as what it was, is like number 2, I think, number 4, have it written that way. Yeah. So the last part says, how much will the new car cost in 3.5 years? So now that we've written this generic formula, we can say, okay, what's the cost when T is equal to 3.5? So C is equal to what when T equals 3.5? So we're going to plug the 3.5 in for T. And we're adding to it that initial amount of 18,000. So order of operations says we're going to do multiplication first. So 900 times 3.5, I don't have that in front of me, is going to be 3,000. Also, if I write my threes properly, 3,150 plus 18,000. And so that gives us 21,500. Obviously, this is, I don't know, some fancy car that increases with time, where most cars decrease in value over time. So I want you to use what we did there, and I want you to try number 3. We're going to come back to number 2 because that's kind of a weird wording, but I want you to think about how we wrote that out in number 1. Let me make sure we have all of that stuff showing. And I want you to try number 3. Okay. So with number 3, I want you to send me your equation first, then your answer. One thing to keep in mind is with number 3, it says a campus fundraiser offers raffle tickets for $10 each. The prize for the raffle is a $350 television set, which must be purchased with the proceeds from the ticket sales. How many tickets must be sold for the raffle profit to be $400? So I want you to think about what it means that they're going to have to use their proceeds to first buy that $350 television set before they turn around and actually turn a profit. So again, what am I asking for? Write an equation, then solve the equation. So remember, I'm talking about, we want to first define our variables, right? So we're looking at selling tickets and making a profit or proceeds, right? So I'm going to say P equals our proceeds. And T is going to be the number of tickets. Okay. So our generic equation is going to have both P and T in it. So I'm going to say that the proceeds are equal to the $10 per ticket, right? But we have to subtract off the cost for the television set, which is $350. Because again, we're reducing our proceeds by that $350 because we have to use them. We have to use them for to purchase the what am I trying to say? Oh my gosh, to purchase the something, to purchase the TV. Thank you, Luke. Oh, my brain is slow.
It's okay. I'm slow too. I'm pretty sick.
I'm not sick, but it's really slow. Maybe I am and I'm just not aware. Speaking of which, if we go back, sorry, I'm looking at comments. I don't know how to add to save my life. Or do I? What am I doing here? What error did I make? In number one, if we have 3,150 plus 18,000, again, don't know how to add. Woo! This should not be 21,500. I was doing it too fast. This should be 21,150. Sorry about that. So going back to number three, we want to know how many tickets we have to sell in order to make a profit of 400. And so we're going to put 400 in for P. And to solve for T, we're going to add 350 to both sides. 400 plus 350 is 750. And bringing that 10t down, we're gonna have 750 equals 10t, divide both sides by 10, and we need to sell 75 tickets in order to make $400 in proceeds, because that 75 tickets includes both the proceeds that we want to make plus the amount of money we need to make in order to buy that TV. Okay. So if we go back up to number 2, it says a snowplow has a maximum speed of 40 miles per hour on a dry highway. Its maximum speed decreases by 1.1 miles per hour for every inch of snow on the highway. According to this model, at what snow depth would the plow be unable to move? So we're looking at the plow not being able to move, which means the speed would be 0. So we're going to say S is equal to speed, and D is going to be to snow depth. And we're going to remind ourselves that it's in inches. If we can spell the word inches. Good night. Okay. So how do I know it needs to be in inches? Well, it gives me the definition that it is decreasing by 1.1 miles per hour for every inch of snow. So we've got to measure the snow in inches. The maximum speed is 40 miles per hour. So this is one where it might make more sense. You know how at the very top I was showing you that you could write it as your rate of change times your variable plus the initial amount, or you could also write it as your initial amount plus your rate of change minus your rate of change times your variable, right? I had said that you could have it both ways, right? When I was talking about here and here. This is one where it might make sense to you more to write it where you have your initial amount first. And so what I mean is that our speed is equal to our initial speed of 40 miles per hour, right? Minus 1.1 times D, because it's reducing by 1.1 miles per hour per inch of snow. Now, the other way, like I said, you could also just write it as negative 1.1 D plus 40, where that's our initial speed is 40 miles per hour. But I think writing it the first way kind of makes more sense in terms of how we're thinking about this, of like, okay, I have my initial speed and it has to decrease over time. Now, if I'm looking at when would the plow be unable to move, I'm saying is what is the depth of snow that would make the speed to equal 0, right? If you can't move, you have no speed. So we're going to put 0 in for S, and we're going to solve for D. So I want you to go ahead and solve for D and let me know what you get. So again, in this equation right here, you are solving for D and sending me your answer. Okay. So subtracting 40, we're gonna have negative 40 equals negative 1.1 D, dividing both sides by negative 1.1, and we get D is approximately equal to 36.36 inches, or about 3 feet, right? 3 feet of snow is going to cause the snow plow to come to a screeching halt. Okay. So again, defining your variables so you know what unit of measure you're dealing with, right? D is being measured in inches, speed is being measured in miles per hour. Those are going to be the things that are going to help you in terms of setting these equations up. Okay. So when we talk about types of equations of lines, there's 3 different models that we have. We have the slope-intercept model, which is what we've been dealing with so far. We have the point slope model, which is what we're going to look at next. And then we have the standard form, which is what we'll look at in 4D. So many students feel uncomfortable with point slope because it looks different than what they've dealt with before. But I think it's really nice and really informative, especially when we don't have the y-intercept, or if the y-intercept's not a nice number, right? Like it's possible for a line across the y-axis at like 2.75, right? That's not really nice to write an equation from, okay? So when we look at this point slope for a line, we have y minus y1 equals m times, and then in parentheses, you have x minus x1. And like I said, it is the point slope equation for a line that has slope m and contains the point x1, y1. Now, you don't need to go any farther. When they say they want it in slope-intercept or point slope form, they just want it that way, okay? So in number 1, it says, given the slope and point, write the appropriate equation in point slope form. So again, when you see the words point slope form, I want you to automatically go, oh, okay, y minus y1 equals m times x minus x1. So we're given a slope, negative 4/3. So we're going to say m is equal to negative 4/3. We're given a point, 1, negative 6. We're going to call the 1 x1, the negative 6 y1. So given the equation, y minus y1 equals m times x minus x1. We're going to plug our values in. Now you'll notice the general formula has subtraction signs in it. So when I plug this value, this negative 6 in for y1, I'm going to do y minus, and then in parentheses, I'm going to do negative 6. So it's telling you y minus that y1 value. That y1 value is negative 6. We're going to do equals. We'll put in our slope, which is negative 4/3. Times x minus 1, okay? Because again, x1 was 1. Now, you can leave this as y minus the negative 6. That's perfectly okay. You can also change it by recognizing that, oh, when I have a double negative in a row, so this is a big or, it's an option. You can reduce it this way. You can rewrite this as y plus 6 equals negative 4. And that's a 3. Times x minus 1, okay? So you can have y minus a negative 6, okay? You can leave it that way, or you can change that minus a negative 6 into y plus 6. And so then this is the final form. That's it. That's all we have to do. So I want you to look at number 2. I want you to write the equation of the line in point slope form using the information in number 2, and send me your answer in a direct message, please. Again, they're giving us our slope of 2. So M is going to be 2. We know that we have an x1 and a y1. Okay. So we're going to do y minus 1 equals 2 times x minus 3. And then we're done. So in the second part here on this page, it says now you're given 2 points. They want you to find the slope and then write the equation in point slope form. So if we're finding the slope, remember your slope formula is y2 minus y1 over x2 minus x1. And we're going to do point slope form. So that's going to be y minus y1 equals m times x minus x1. So we're just going to start by finding our slope, right? As I've said before, I'm lazy. I just will number or identify my ordered pairs as I move from left to right. So I'm going to say x1, y1, x2, y2. So plugging them in, I'm going to have -1 minus 3 over 3 minus 5. -1 minus 3. Remember, if you struggle with this concept, right, and remembering that I'm at -1 subtracting 3, I'm going to be more negative. You can rewrite this to be -1 plus -3. Much like in the denominator, I can have 3 plus a -5, right? Those are still equivalent statements. In the numerator, -1 plus -3 is going to make -4. In the denominator, 3 plus -5 is going to make -2, which when we reduce this slope, we get +2. Okay. And then you can use either point to write your equation. Okay. So moving back up top, I have an x1 and y1. We can use those. So we can say y minus 3 equals 2, right? That's the slope I found, right? That's the slope, times x minus 5. That is a valid equation here, okay? Or I can also write y minus a -1 equals 2 times x minus 3, right? I can use that second equation, or excuse me, that second order pair in order to write my second equation. So both of them are going to be valid. Now, if we go over Desmos, I like to show how this works, just to kind of reiterate the fact that these are both the same. So if I plug in the first one, y minus 3 equals, and then 2, and then we're going to do parentheses, x minus 5 and parentheses. So you can see we've got that red line going, right? Now, for the next one, I'm going to do y minus, and then I'll, in parentheses, I'm going to do -1. You don't really need the parentheses, but I'm making it match like what we have, equals, and then still that slope of 2. And then we're going to have x minus 3. And now you can see the blue line is now completely on top of the red line. Okay. Now we can see just from looking at this, right? If we click on the thing, on the line, excuse me, the thing, you can see that the slope is 0, -7. We can transfer these equations from point slope form into slope intercept form by distributing, excuse me, and then isolating our y variable, and we'll do that on the next page. But I just wanted to show you that you can come up with some of this information just by graphing the equation. Okay. So what I want you to do in number 2 is I want you to find your slope. And then write the point slope equation. Let me share my screen, my normal board with you again. Okay, so go ahead and find your slope first, then find your equation. And you can just wait and send me the answer as your equation, okay? Okay, so if we find our slope, we've got y1, or y1, oh man. x1, y1, x2, y2. So finding the slope, remember, is y2 minus y1 over x2 minus x1. So plugging these values in, I'm going to have -2 minus a -5 over 3 minus a -1, okay? So minus minus, both of these are going to become plus signs, right? So what that means is we end up with -2 plus 5 over 3 plus 1. This gives us a slope of 3/4, right? And so writing our equation, you can choose to use either ordered pair. It doesn't matter which one. I'm running out of room. I'm going to just use the first one because again, I go with whatever's first. So I'm going to say y minus a -5 equals 3/4 times x minus a -1. If you're uncomfortable with all the minus negatives, we can rewrite this as y plus 5 equals 3/4 times x plus 1. And it can be good to, oh my gosh, it can be good practice to write it that way, because when we get to the next section, you'll notice that we want to graph these lines, and oftentimes the lines are written with plus signs instead of the subtraction signs that the general format is written in. And so it's good to be able to recognize going between the minus -5 to a +5, right? The relationship that exists between those two, okay? So if we go to the next page, we're not going to do number 1, but we are going to do number 2. So it says, given the slope and point, write the appropriate equation in point slope form, then translate it to slope intercept form. So if I'm going to write this in point slope form first, again, I'm focusing here on number 2. And the reason why I'm not going to do number 1 is that we got to deal with the fraction, and it's kind of a pain in the butt. And so we're just going to focus on doing number 2 because I want to show you the process is what's important here. So remember, point slope is going to be y minus y1 equals m times x minus x1. But then slope intercept is y equals mx plus b. Now, important things to notice between those two formats: one has parentheses, one does not. One, the y value is isolated, the other one is not. So when we're moving from point slope to slope intercept, we're going to distribute that slope through that m in order to clear those parentheses. And then we're going to add the y1 value to the right side in order to isolate y, okay? So looking at number 2, they're giving us our slope, they're giving us our point. Again, if we label our point, it's going to be x1, y1. Just practicing this, I know it feels silly to do it over and over and over again, but that way you don't forget what are the pieces you need. So we're going to do y minus 2 equals 3 times x minus 4. So right now we have fulfilled the first question, or the first part, which is write it in point slope form. We're now going to translate it into slope intercept form. So we're going to take this 3 and we'll distribute it through, right? So we're going to have y minus 2 equals 3 times x minus 3 times 4. Simplifying, we have y minus 2 equals 3x minus 12. And then we need to move that 2 to the right-hand side. So we're going to add it. And we get y equals 3x minus 10. So now looking at this form, we can still identify that we have a slope of 3, but that we have a y-intercept of -10, right? We can see that piece. And so when we were dealing with this on Thursday, right, when I was giving you a slope and a point, and I said, okay, write it in slope intercept form. We were first plugging those values in for x and y and solving for b, and it was this whole extra step to rewrite the equation. Well, now that we know about point slope form, we can write those equations in point slope form first, and then translate them to slope intercept. And we don't have this extra step of like substitution and all of that. So again, we're learning a new piece of information that can be helpful when we go to solve these problems. So as I said before, we want to be able to graph these equations. And when you're looking at graphing, you want to always go back to the generic form of the line. So it says identify the slope and the point from the equation and then graph the equation. Now remember, this is written in point slope form, which is y minus y1 equals m times x minus x1, okay? It's important to remember that those subtraction signs are there so that we can line up the important pieces of information in order to be able to pull those out to graph it. So when I say line them up, if I write that generic form underneath, you'll notice that if I don't include the subtraction, because we don't want to, because that's part of the general form, you can see that we have these three pieces of information. I'll let my board catch up. Okay, so we can see from the green boxes that I drew in the middle, the slope is 1/2. Okay. Also, we can see what is the ordered pair there. Well, the x1 is 1 and the y1 is 2. Therefore, the ordered pair is going to be the point 1, 2. So if I go over to my graph, I'm going to start by graphing that point 1, 2. So over 1 up to 2. And then I'm going to use my slope to get to the next point. So going, remember this slope, if we interpret that, it's going to be up 1, right 2. So we're going to come up 1, right 2, up 1, right 2. And we have a whole bunch of points, which will allow us to graph our line. A little sloppy when I do it on here, but again, beauty of my math lab is it allows you to plot those that 1 point first, and then you can use the arrow keys to tick up to the next point. So if we go to the next page, number 2, this is what I was talking about, being able to recognize what the plus signs mean, right? So I have y plus 4 equals 3 times x plus 1. But remember, our general formula is y minus. So we need to push this equation into being in that format that's going to have subtraction. So we know if we minus a -4, that's the same as adding 4. So we can rewrite this equation as y minus a -4 equals 3 times x minus a -1. Again, this is why I was saying, okay, we want to look at how we move back and forth between these two models. So now when I write my equation underneath, I can identify the values that match up more easily because I have that subtraction sign that I'm supposed to have in front of the value. So from here, I can see that my slope is 3, which we rewrite as 3/1, right? You have to have it as a ratio of a vertical change over a horizontal change. And then my x1 is -1, my y1 is -4. Therefore, that is the point -1, -4. So I'm going to let you use those two pieces of information, use that ordered pair, use that slope to graph the line on the right-hand side. So if we graph it, we're going to go to the point -1, -4. So over 1, down to -4 right here, right? To the left and down. And then we'll use our slope by going up 3, right 1. So 1, 2, 3, right 1. 1, 2, 3, right 1. And we can see the line should approximately look like that. Okay. I'm gonna give you a little piece of information for number 3 before I ask you to solve the rest of it. Something that's weird about number 3 is that it just says so it's y plus 2 equals negative and then x minus 3 inside the parentheses. That's not a lot of information, but what they're not telling you is that that's a -1 in front of the parentheses. Okay, so if you just see a minus in front of it, I want you to think of it as being a -1. So what I want you to do is in number 3, I want you to identify your slope and your point and send those to me, and then graph your equation, okay? Okay, so remember our generic formula is y minus y1 equals m times x minus x1. So we want subtraction signs to be there. With the y plus 2, there is not a subtraction sign. So we have to rewrite this as y minus a -2 equals -1 times x minus 3. In the x minus 3 portion, there is a subtraction sign there. So we're good. If we write our generic formula underneath, and we identify the common pieces, again, we're excluding that subtraction sign from the information because the generic formula has the subtraction sign in there. We don't want to include it when we're identifying the ordered pair. Obviously, for y1, we had y minus a -2, so y1 is -2. So our slope, first of all, is -1. Our x1 is just +3 because again, it's x minus 3, so we only want the 3 portion. And for y1, because it's y minus a -2, we want the -2 portion. So our ordered pair is going to be the point 3, -2. So again, we're always starting with that when we're graphing. So we're going to go to 3 down to -2, and then our slope being -1. Okay, we interpret that as down 1, right 1, right? If we write our slope or whole number slopes, we write them as a fraction, right? So we're going to be -1 over 1. So I'm going to come down 1, right one and get to my next point, and then I just stair step using that slope. I can get, and the nice thing about doing these by hand is it allows you to see, oh, there's a nice line there of all of these points. And so then we can connect them. And there you go. So as we're getting used to these, I really suggest writing it out, massaging it to get it to look like our generic formula, which is that y minus y1 equals m times x minus x1. Write that formula over and over and over again, because the more times you write it, the more times you practice it, the better it'll, the easier it'll be to remember it. So every single time, write it out. Push your equations to get into that form in order to graph them, okay? So our schedule has us doing a little bit of 4D, and so I'm just going to get into that a little bit, and this is just that last form of a line that we want to talk about, which is standard form. And standard form is when we have x and y on the same side of the equal sign, okay? And so again, we've had slope intercept form. So if you're keeping track of all your forms, we have slope intercept form, which is y equals mx plus b, which, why is that important? How is it helpful? Well, m is your slope, b is your y-intercept, right? And we would write that as the point 0b, right? So after that, we have the idea of the point slope format, which is what we were just talking about, right? We have point slope, which is y minus y1 equals m times x minus x1. Oops. And why is that helpful? Well, we again have our slope. And oops, and then we have a point, and that point is just the point x1, y1. So instead of having the specific y-intercept, we're still given information about a point in the equation, but it's just a random point, okay? So the nice thing about standard form is we can easily find our x and y intercepts from it, and we can generate those ordered pairs in order to graph the line. So any equation in the form ax plus by equals c, where a, b, and c are all real numbers, and a and b are not both 0, that equation is considered linear. Also, the equation in the form of ax plus by equals c is also to be said a linear equation in standard form. Now, where this is really helpful is, like I said, we can generate our intercepts. So the y-intercept is the point where a graph crosses the y-axis, and the x-coordinate of the y-intercept is always 0. So the y-intercept we would write as the point 0 and then some value, okay? Well, the x-intercept is the point where the graph crosses the x-axis, and it's the coordinate, the y-coordinate of the x-intercept is always 0. So that means if we wrote it as an ordered pair, we'd have some value for x, but then 0 for y. Now, why is this helpful? How is this helpful? And it's because it can make it easy for us to identify those 2 points to graph the line, okay? So in number 1, I have, it says 2x plus 4y equals 20. Now, using this method of finding intercepts, it's really helpful when that value on the end, in this case 20, is divisible by the two numbers on the left-hand side, the coefficients, the values in front of those variables. This method is really helpful when that value on the end is divisible by those two values. So what I'm talking about here is that I have 2x plus 4y equals 20. Well, 20 is divisible by both 2 and 4. So we want to find the X and Y intercepts to graph the line. So if I want to find the X intercept, remember at the X intercept, that's where Y equals 0. Because it's the point at which where it crosses the X axis. So it's crossing that X axis, which is this axis right here. Okay. If it's on that line, you are not moving vertically, right? It's on that line. So your Y intercept there is 0. So we're going to plug 0 in for Y. So we'll have 2x plus 4 times 0 equals 20. Plugging that 0 in for Y is great because it causes that term just to drop out. And we're left with 2x equals 20. We'll divide both sides by 2. And I get x equals 10. So if we write that as the ordered pair, that's going to be the ordered pair of 10, 0. Okay. So if we go to our graph, 10 on the x-axis is right here. And then there's the 0 for y, means I don't move off of it. I just am right there. So that's the x-intercept. Now we want to find the y-intercept. And that remembers the point where x equals 0. So plugging 0 in for x. Oops. To actually plug it in for x, you can't just write x there again. So we have 2 times 0 plus 4y equals 20. The 2 times 0 is just 0, so it drops out. So I end up with 4y equals 20. Divide both sides by 4, and I get y equals 5. Which again, what does that mean? Well, that is the ordered pair. Let me let my board catch up. That's the ordered pair again, where x was 0 and y is 5, right? That x equals 0. We have to use that in order to generate that ordered pair. So we are going to now graph this point. We have 0 for x, 5 for y. And so there is that second point. And we can graph our line. Now, in your homework for this section and for the quiz over this section and in the test, you want to be really careful when it's telling you to graph the line, because it might give you a line in slope intercept form and say graph it using the intercepts. That means you would need to find the x-intercept and the y-intercept. So sometimes I get emails from students and they're like, God, it's exactly the same as what they're asking for. And the reason why they're marking you wrong is because you're not putting those 2 dots that we form the line on the specific points that they want you to use. Okay. And I know that's frustrating. But we're asking you to practice. Can you find those intercepts? And then can you graph the line using those intercepts? So it's again, it's a skill that we're having you practice. So I want you to think about what I did in number 1. Look at number 2. I want you to find your x and y intercepts. And I want you to send me those ordered pairs and then graph your line. Okay, so the x-intercept, that's where y equals 0. So we're gonna have x plus 3 times 0 equals 6, which means we have x plus 0 equals 6, meaning x equals 6. So that's the order pair 6, 0. For the y-intercept, that's where x equals 0. So we're going to have 0 plus 3y equals 6. Again, the 0 part just drops off. Dividing both sides by 3, we get y equals 2. So that's the order pair 0, 2. So graphing those 2 points, we have 0, 2 is right here, 6, 0 is right there. And drawing our line. Now, one thing we haven't talked about is how we can identify our slope from our graph. Like you can see we have the 2 points and we could use those order pairs to come up with the slope. But we can also see it from what we call the slope triangle. So when I'm saying the slope triangle, right, my cat's trying to get something that they shouldn't get. We're talking about this triangle right here, right? It's the point, the triangle that's formed from going from one point to the next. So to go from, say, point A to point B, we are going down 2, right? We dropped down 2 and going right 6. So our vertical change is -2, or horizontal change is 6, giving us a slope of -1/3. Right? That's a way that we can physically find the slope from our order pairs on the graph. Okay, and we can even see if we come in here with a different color and we come down 1, right 3. Oh, look, that point was on my line. Down 1, right 3, and then we get to point B as well. All right, I just wanted to kind of tell you that on the side because we hadn't really talked about it formally. We have reached, I'm going to call us for time for today, so we can kind of let all of this stuff sit in our brains, right? So in case you have not taken your exam yet, it is due today. Make sure you take your exam, right? If you have not contributed to the class data for the penny flipping, that is also due today. Tomorrow's class is optional, but I'll be here. So if you have questions about Unit 4 or the project, great time to log in and ask me questions. And then on Thursday, we will pick class up again and we will finish with 4D and do 4E. So, questions for me before I let you go?
I'm good. Have a good day.
You too, Luke. Feel better soon.
I'll try. Thank you.